I said, so we're gonna uh, finish with, we're gonna try and not finish it because there's a lot left. Like electrolysis. Okay, we're doing electrolysis, and in electrolysis, well, we'll just do one very quickly. Okay, electrolysis way we had uh, we had the whole cathode anode thing, and so just 1 second. So we had the whole cathode anode thing going on, which was that you've got electrons coming in, the battery electrons from one side, and it's taking away electrons from the other side. So one side becomes negative, it's got too many electrons, the other side becomes positive, that's the anode. And what you had in the solution was that I'm going to put some random stuff just for revision, TK, and then we're going to move on. So if I have uh, क्या चीज हो, so let's say I have some potassium bromide in liquid state in this solution. Not a solution, it's in molten state. So the positive ions in potassium bromide are going to be attracted to the negative cathode, and the negative bromide ions are all going to be attracted to the positive anode. And what the battery would do is it's going to throw electrons at them, and the potassium over here, the positive ions which are getting attracted to it, they would have to end up, they would end up gaining electrons. So your equation would be that your potassium ions will get electrons from the battery and they will become neutral. And this is called reduction. Gain of electrons is called, you can remember the word for gain of electrons, that is reduction. So potassium ions, they get reduced. On the other hand, what happens to the bromide ions, the Br, remember group 7, so it's got a negative charge. The battery is going to be pulling electrons out of them. So what will happen over there is that your Br minus 1 ions, the battery is going to take away electrons from it. So it's going to become neutral, and the extra electron, because it had a negative charge indicates that it had extra electrons. The battery is going to pull that electron and take that electron away from it. So those were your two equations. This is known as oxidation. There's only loss of electrons. Remember the word used for loss of electrons, that's oxidation. Okay. Now there's only one problem, and that problem is that the bromide ions, your bromide ions, they are diatomic, which means that they will never exist. That's what I get. I said they'll never exist as single atoms. They'll always be existing as diatomic molecules. So there has to be two Br ions, and they would together lose two electrons, and it will form two Br atoms, which will join together to form a Br2 diatomic molecule. Okay? Remember, the only thing you have to be careful about when you're writing equations is that there are certain elements which are always diatomic. Group 7, entire group 7 is diatomic. And apart from group 7, there are three more. There's hydrogen, oxygen, and nitrogen. Those are diatomic. Anyways, that's what you were up to, right? But then we started with aqueous solutions. Now, the only difference in aqueous solutions was that you had more than two ions. NaCl aqueous means that it's not just going to be sodium ions and Cl ions. They're going to be more than two ions. And those two ions are coming from water, because water likes to, some of the water molecules, they break down and they produce H+1 and OH ions. So your solution is going to have, it's apart from sodium ions, it's also going to have H+1, and it's also going to have OH-1 ions as well. And so now you've got competition. Now what happens is that the battery is throwing electrons, Now you've got two options. Either it's sodium that's going to gain electrons, or it's going to be H+1 that will gain electrons that's coming from water. So how do you decide who gains electrons? Because one of them has a greater tendency to gain electrons. And who decides who gains electrons? That can
The
be found out.
reactivity seems so.
You get the reactivity seas. So remember, in the reactivity seas, especially when you're talking about ions gaining electrons, it's the bottom of the reactivity seas, the ions, uh, the elements that are unreactive. They are the ones that have a very high tendency to gain electrons because they don't want to form ions. Gold does not want to form ions. Gold wants to remain as gold. Gold never wants to form ions. So, which is why if gold ever forms an ion and it sees an electron, it will quickly grab onto it. So that means gold has a very high tendency to gain electrons, which is why it's very unreactive because it never wants to lose electrons. Metals always lose electrons when they react. Potassium is very reactive. That means potassium really likes to lose electrons. It likes to form ions. It doesn't like to do the opposite. It doesn't like to form the potassium metal back again. So remember, in the reactivity series, when it comes to gaining the electrons back, it's always the unreactive, the ones that are at the bottom. They're the ones that really like to gain the electrons back because they never wanted to form ions in the first place. They were very unreactive. So in our case, we had the competition was between sodium and H. Sodium is higher up in the reactivity series. Sodium likes to form ions. It likes to lose electrons. It doesn't like to form the metal back again. Hydrogen, on the other hand, is slightly at the bottom of the reactivity series. So you're going to select hydrogen. So between sodium and hydrogen, it's the H+1 ions that will basically gain electrons and they'll end up forming H2 gas bubbles. Okay. Now on the other side, the competition is between OH ions and Cl ions. And you have to decide who loses electrons between OH ions and Cl ions. Uh, for that, there's another series that you got to remember, and that series is that it's this one. It's I minus one, Br minus one, OH minus one, Cl minus one, and then it's the rest of the ions. So again, in this series, it's always the bottom one that's the one that's going to lose electrons. So the bottom ones are the ones that lose electrons. Okay, so this is your series that's going to, so the question is who loses electrons? So you're going to state the ones, whoever is at the bottom, right? I said now there's one thing that you got to remember. The anode series is pretty easy to remember because your syllabus is quite limited when it comes to anode. What you can actually remember is that it's always OH ions that lose electrons or get oxidized. Remember, oxidation is the word for losing electrons. Unless the halides are concentrated. So you can kind of get away and you don't have to remember the entire series because your syllabus is very limited when it comes to anode. So just remember it's always OH minus one that you're going to select, except if the halides are concentrated. Halides are Cl minus one or Br minus one or I minus one. So you don't really have to remember the entire series. It would be good if you do remember it, but I mean this statement over here would be sufficient. So our competition is who's going to lose electrons? Is it going to be OH or Cl? So what is the rules at the anode? Then it's always going to be OH ions, except if the Cl ions are concentrated. which they never told us. They never told in the question that Cl ions were concentrated was NaCl aqueous. So they never said that Cl ions were concentrated, right? So we're going to select, so I'm going to write the equation over here. That is it going to be OH ion or is it going to be Cl ions? So you're going to go with OH. Now there's one trouble with OH, and that is that for OH, you can't really make the equation. You have to remember the equation of OH ions losing electrons, which is it's going to be 4 OH ions and they'll lose electrons and they'll form 2 water molecules, an oxygen molecule, and they will lose a total of 4 electrons. This equation is something that you got to remember, that when OH ions, remember, got a negative charge. The rule is, like, if you look at the series, it's actually, is the screen lagging for everyone or is it just lagging for me?
Sir, yes, it's also lagging for us.
Let me just just one second. I don't know why it's lagging. You know, I'll slow it down when I move the screen. I think it's okay for the beer. Yeah, I think it's probably then if it's working for one person, then that means probably a Zoom issue. Maybe sit closer to the internet then. So, anyways, I'll slow down the movement of the screen. Anyways, I said Taha, OH ions are going to lose electrons when it's a competition between Cl ions and OH ions. The bottom ones are the ones that really like to. Nee, Taha,
Sir,
see, I told you, here's the rule. The rule is it's always OH ions that lose electrons unless they say that it's concentrated. Okay, is that clear? If they,
yes,
if
sir. Just that I saw in the book, like they wrote that the most likely to discharge is Cl before OH.
no,
They wrote ionide, bromine, Cl, and then after it OH.
Cl and then OH. I said this one, right? You're talking about this one. You're saying that the book wrote
Yes,
I minus one, Br minus one, and
Cl, then
then
Cl.
Cl. I mean, that's what I'm saying. There's going to be a lot of confusion. I said, now, this is very important. Remember, every website or book or YouTube channel that you open, this series is going to be written slightly differently. The one that is over here. So, what I'm going to state, you're going to stick to it. You check this everywhere, it's going to be different. And remember that this confusion over here is going to be, I mean, you're going to get out of this confusion when you do A levels, because in A levels, uh, they are calculated values that you use to figure out which one discharges. But the important thing now that you have to remember is don't trust any book or any website or other any other source. We have to just follow the syllabus and what the syllabus tells us. Because your syllabus is very limited. Because I don't have to go into. Nee, that's right. That's right. Now here's the thing. Okay, let me tell you. Even the books are actually going to be incorrect because some of the books are not following the syllabus entirely. And I'm going to show you this. Just one second.
For
Just
which
give me.
ions will make, sir?
Anode pen. The problem with the anode is that the list of the ions and the ease of discharge, there's a lot of difference in a lot of books. and a lot
Neighbor,
of
what will they make, sir?
the one
2H2O, O2 plus H2?
नहीं वो तो ठीक है प्रॉब्लम वो ऑर्डर में है the order in which just give me 1 second. Yeah, again coming to this or hydrogen oxygen fuel cell, yes. ठीक है ताहा stick to this thing. Always OH minus one unless the halides are concentrated. So look at the book, see if they've mentioned concentrated or not. Or simply trust me, this is what you're going to follow. No matter what book says what, just follow this thing. Always you're going to go with OH ions unless the halides are concentrated. Is that clear? Even ignore this one. I mean, your syllabus just is limited to this part. You don't have to go into details about this. Yeah, I've double checked. There's no difference yet. I mean, they haven't changed anything. So you're just going to stick with this. So whenever you see concentrated, you're going to go with the halides. They're the ones that are going to lose electrons. And the reason is because your syllabus is very limited, so you don't have to like go into the details about what the order or how the order switches when the concentration changes. So you don't have to go into all of that detail. So just simply stick to this. That's it. And for OH ions, losing electrons, OH are negatively charged. When they lose electrons, uh, OH has 1 electron extra, that's -1. And when it loses electrons, there are 4 of them, so they're going to be lost. 4 electrons would be lost. And water molecules and oxygen molecules are going to be produced because the OH decomposes and breaks down. So I'm going to do the next one, and I would have to I have to copy this. So next one for aqueous solutions, we're going to do a couple of them.
Sir, NaCl will remain unreactive in this.
Unreactive, 1 second. I said, so in this one, I will also write that oxygen gas bubbles, so colorless bubbles of O2 gas would be produced. So what has happened is that on one side it's H+1 that is getting discharged, and on the other side it's OH ions that are getting discharged. So your solution is going to become more concentrated because on one side H+1 is going, on the other side it's OH ions that are being removed. Okay, so your OH ions are also leaving. So over time, what's going to happen is that your solution is going to become more concentrated because water is being removed. So solution
तो मतलब NaCl
becomes,
का कुछ भी नहीं होगा.
I mean, NaCl remains. The only thing is that water would be gone because H+1 is turning into H2 gas and your OH ions are turning into oxygen gas. And they're also forming bubbles. So on both sides, you will start seeing bubbles of gas being formed. And nothing happens to NaCl. So solution becomes more concentrated because water is leaving the solution. It becomes more concentrated. Is that clear?
Yes.
I said next one is just 1 second. So the next one is we're going to try NaCl concentrated now. And we're going to see how everything changes. So NaCl aqueous, but now it's not dilute, but it's concentrated. So your solution is going to have sodium ions, which will be attracted to the negative cathode. And it's going to have so it's going
Then
to
in this
have
case, dilute means that there will be less NaCl present in the solution.
and there's going to be more water, right?
Alright.
Over here, it's concentrated. So there's going to be H+1 and there's going to be OH-1. Now again, the question is who gains electrons? So who gains electrons that are coming from the cathode, from the battery? Is it going to be Na+1 or is it going to be H+1? Nothing changes at the cathode. You have to look over here in the reactorices. N is at the top, H is at the bottom. So you're going to go with H. H is right at the bottom. So you're going to go with H. H is the one that's going to gain electrons. So I'm going to write the equation. It's going to be H+1 gaining electrons and turning neutral. And it's diatomic, so that means I have to double everything and two H atoms would be produced and they'll form H2 gas molecule, and that's my equation at the cathode. H2 is a colorless gas, so you'll see bubbles of H2 gas. And if you want to test it, it will burn with a squeaky pop sound. Okay, that's the test for H2 gas. You introduce a burning flame, and it goes out with a squeaky pop sound. Now, what happens at the anode? Who loses electrons? That's the question. So
Chlorine.
who loses electrons, whether it's going to be Cl-1 or OH-1? Now, the rule over here at the anode is that it's always OH-1 that loses electrons unless the halide is concentrated, which it is. I mean, they've told us that it is concentrated. So if your halide is concentrated, then it's going to be Cl ions that will lose electrons. And so I'm going to write the equation of Cl ions losing electrons. They've got one extra electron, so they'll become neutral. And an electron would be lost. But Cl is diatomic, which means I have to double it. So 2 electrons would be lost. 2 Cl atoms would be produced, and they'll end up forming Cl2 gas molecules. So that's what my reaction is going to be. And remember, Cl2 gas is greenish yellow. So you'll see greenish yellow. Gas bubbles over here. And so in your solution, what is gone? On one side, it's H+1 that has left because it has formed bubbles and it's gone. On the other side, what has happened is that it's Cl ions that are gone. So now, what are the changes that are happening to your solution? Initially, you had NaCl concentrated, but since your H+1 is gone and your Cl-1 is also gone, what are you left with? You're left with NaNOH. So it's turning into NOH. Okay, because H and Cl are gone. So what you can write is that the solution turns into an alkali. It turns alkaline. Remember, hydroxides are basic. So solution turns basic. Or you can use the word alkaline. Remember, both of them mean exactly the same thing, basic and alkaline. You use the word alkaline when you have a base that is soluble. Okay, NaOH is a group 1 base, and it is a soluble base. So that means it will turn alkaline. It will mix with water. and it will become NaOH aqueous. Okay. So remember two things. You'll be asked about observations at the cathode, you'll be asked about the equations at the cathode, you'll be asked about the equations at the anode and the observations. You can remember the equation and the observation. They're two different things. Okay? When they're asking about observations, they don't want the equation. They just want what you're going to see. And when they ask about the equation, they don't want to. You have to write the equation in that case. Okay? And the third thing they're looking for is the changes that are happening in the solution. So your Cl and OH are gone, Cl and H are gone, so you're left with NaOH. So that means NaCl aqueous has now turned into NaOH aqueous. Okay? Is this clear? Fatma, Ahmed, Rania, is this clear? Zar,
Yes.
Zainab? Okay.
Yes, sir.
Yes, sir.
So let's try and do the next one, which is, let's do copper sulfate now. So exact same diagram. Get rid of the ions, the anode and cathode are there. And I'm going to add copper sulfate, aqueous. Now, when you have copper sulfate aqueous, it's going to have copper ions, which will be attracted to cathode. It will have sulfate ions, which are SO4 minus 2 ions. And it's going to have, because it's aqueous, it's going to have H plus 1. And it's going to have OH minus 1 ions. So the question is, who gains electrons? Is it going to be copper plus 2 or is it going to be H plus 1? The battery is sending electrons. So you got two options.
Copper will gain copper.
Okay, so you look at the reactivity series, which is over here. And in the reactivity series, you've got H in the reactivity series. So you've got H, and copper is below H in the reactivity series. Here, copper is right below it. So it's going to be copper that has a greater tendency to actually gain electrons. So we're going to go with copper. Okay. So we're going to go with copper. So you'll have copper plus 2. And it needs, how many electrons? It needs 2 electrons. And it will become copper. Because that is what your equation is. It's going to be copper that gains electrons. Now, copper is a metal, so copper metal would be formed. And you would start seeing deposit of copper forming on top of the cathode, because that's where all the copper will deposit. So the observation that will be over here is that, remember, copper is a pink, shiny metal deposit. Is formed.
So is it mandatory to write the observation in the like exam paper?
If you look at we'll do questions. If he says observation, you don't have to write the equation. You would just have to write the observation.
No,
Yeah,
sir.
if
Like, is it mandatory to mention the observation in every question?
If he's not asking for the observation, you don't write the observation.
Okay.
But if he's just asking for the reaction, right, you write the equation. Observation is only written if they ask you for the observation. So on the anode side, who loses electrons? The battery is pulling electrons. So is it going to be OH minus 1 or is it going to be SO4 minus 2? So the rule over here is that it's always OH ions unless you have a halide that is concentrated. So there is no halide. I mean, there's just OH ions. So you're going to go with OH ions, and for that you need to remember the equation. It's going to be 4 OH ions and together they're going to lose 4 electrons, and they'll form 2 water molecules and an oxygen gas molecule. So what you're going to see, the observation would be that you will see bubbles of O2 gas. If you want to test the O2 gas, what is the test for O2 gas? That's you'll see it burns with a lighted, so it relights a glowing splint. So you'll see bubbles of O2 gas. So what is happening to your solution now? Copper is gone because all of it got deposited, so it's no longer part of the solution. And on the other side, it's OH ions that are gone. They've turned into oxygen gas and they've formed bubbles and they've left as well. So your copper sulfate now is what? It's what is left in the solution? It's H plus 1 and SO4 minus 2. So H plus 1 and SO4 minus 2 will form sulfuric acid. So the observation in the solution is that, remember, copper sulfate was a blue colored solution. So blue copper sulfate aqueous turns into acidic and colorless. H₂SO4 is colorless. So it slowly turns into sulfuric acid because copper and the OH ions are gone and you're left with basically H₂SO4. Okay, is this part clear?
Yes, sir.
Yes, sir.
So that's and remember this thing, copper sulfate, this entire thing, this is like the favorite part. I mean, this is, I'm going to write, I mean, any question on electrolysis, there's a 80% chance that it's going to be on copper sulfate. So I'm just going to highlight that this is going to be very important. And I'm going to just repeat what are the questions they're going to ask you. They're going to ask you which ions get attracted to cathode. So that's obviously H plus 1 and copper plus 2. They can ask you to label the diagram if they draw a diagram, like which one is the cathode, which one is the anode. They can ask you about what ions get attracted to anode. So that's OH minus 1 and SO4 minus 2. They can ask you about the equations. Who's getting reduced and who's getting oxidized? Remember, gain of electrons, that's reduction. I'm just going to repeat this. Gaining electrons, that is reduction happening. Gain of electrons, reduction, same word. Who's losing electrons? That's called oxidation. They're going to ask you about the observation. You should know that copper is a pink metal. And so I'm going to write a few things about observations if they ever ask you. So you should know what are the colors and what do you have to write when it comes to observations. So for example, let's talk about colorless gas bubbles forming. Who's got colorless gas bubbles? It's a lot of gases are colorless. Oxygen gas can be obtained in electrolysis. You've got hydrogen gas. You've got plenty of other gases as well, nitrogen gas, etc. So there are plenty of gases that are colorless. Then you've got a few gases which are colored. I just know one of them, which is Cl2. That's greenish yellow. So then you have what else? You've got Br2. Remember, that's a red brown liquid. And it's a volatile red brown liquid. So, or you can also write red brown vapors. Volatile means that it evaporates very, very quickly. Similarly, you've got it's going to form vapor, especially at high temperatures. Then you've got iodine, which is, what is the color of iodine? That's a gray black solid. If it's a solution, it's brown in color. And if it's a gas, it's purple vapor. You would have to watch out if they're talking about H₂ aqueous, that's going to be a yellow-brown solid, yellow-brown solution. Sorry, it's going to be a yellow-brown solution or a brown solution. If they're talking about H₂ gas that's forming, it's going to be purple vapor. And if it's solid, then it's going to be a gray-black solid. Acha, what else? If metals form, then what you're going to write? You're going to write that it's going to have a shiny, metallic deposit, and especially if it's copper. For copper, it's going to be it's going to be pink in color. You've got other things as well. Silver is obviously going to be a silver shiny metallic deposit. If it's gold, then gold is going to be yellow in color. If you have other metals, then they're mostly grayish in color. So you're going to have a gray shiny metallic deposit. ठीक है? अच्छा चलें ठीक है. Let's sum this up. We're done with aqueous solutions. We're done with electrolysis of aqueous solutions. All you have to do is you have to remember at the cathode, that's the difficult part. You got to remember that it's always the lower one in the reactivity Cs at the cathode. And at the anode, it's always going to be OH ions unless the halides are concentrated. Then you're going to go with the halide. Otherwise, it's always going to be OH ions. And for OH ions, you have to remember the equation of them losing electrons. That's the equation that's right in front of you, TK. Then let's continue tomorrow. And we'll try and do electroplating tomorrow. TK, if you have any questions, let me know.
So does electrolysis come in P6?
Anything, so remember P6 is anything that's that has something to do with experiments. So this is something that's related to experiments. So exactly this,
Which topics are the most important that will come in P6?
these are preparation of salts, electrolysis, pK, rate of reaction. You're not going to be, the atomic structure is not going to come in P6. Anything that's related to an experiment. Okay? I mean, chemical bonding will not come in P6. Anything that's related to experiments, separation techniques will come in P6.
The organic chemistry?
The organic chemistry, very highly unlikely that it will come in P6. Is there any, let me think, organic chemistry, if there's anything that's related to experiments in organic, no, there's not, it's probably just the
Like
part for
polyesters,
that,
polymerization.
that won't come in P6. I think the only, maybe fermentation might come in P6 because that's an experiment, right? You have to ferment sugars to form alcohols, right? Or something like that, or maybe or was the P6, the reflux thing, right? Oxidizing alcohols. that can come in P6 because the reflux is something that is related to experiments. So like in बात समझ आइए, it's just going to be stuff that has something to do. So electrolysis is very important. It's something that's very important for P6 as well. ठीक है, clear है? ज़रा clear है? चलिए ठीक है,
Yes, sir.
we'll continue tomorrow then, ठीक है?
Okay, Allah Hafiz.
Okay, take care.
Love.